Hello guys, good afternoon. My name is Dotcom from this table of Cenidea Limited. Today we want to begin a series on DevOps. So it will be on DevOps, but obviously we'll take in the DevOps we'll pick topics by topics, and the topic of today would be Helm Charts. So let's start this series of Helm Chart, and obviously it's going to be the latest Helm Chart, which is 3.0. So let's start our journey today. Will be on Helm. So what exactly is Helm Chart or Helm? Well, what is Helm? Obviously, the definition of Helm Chart is that it is a package manager for Kubernetes. It is designed to obviously simplify the deployment and management of application through reusable packages called charts. Essentially, what is that really? This is just Helm Chart in a layman term. Is just a package manager, like a library basically, that is used to automatically generate a Kubernetes manifest, and then used to make some configuration and tweaks on the manifest and generate it and then deploy the Kubernetes infrastructure inside the cluster. So that's what it is really, and it has the key features. Some of the features are like it has streamlined deployment process or processes, version control for the application. So basically, when you Helm Chart sort of helps you to streamline your deployment in terms of once you generate it, you can just make a few tweaks to it, and then it would automatically generate your or it would bootstrap your manifest straight away. In terms of version control, it's like it will, when you use Helm to deploy an application, it can actually just go back, go forward. Okay, so and then the third one is the reusability of charts across environments. So obviously with one chart you created is going to be used across environments, because it has this thing called value, which we'll get to in a minute. But values helps you to, or value helps you to override the some changeable values within the charts when it's trying to generate the manifest for you. Simplify configuration management as well. So it has, obviously, as we described, everything in it is simplified, because it gives you this value interface where you can just change the values and again, the next thing would be, why would someone use Helm? Basically, obviously, as alluded here already, it helps with the efficiency, consistency, and rollback capabilities. In terms of efficiencies, it's like to automate complex deployment with simple commands. So it has its own unique set of commands that you can issue, and it will deploy your application. And again, consistency actually. So here, it ensures the uniform configurations across different clusters, if you may, or if you want to use that. And it can just easily revert back, or probably just deploy new versions of the application once a few changes are made. Okay, so let's moving on. The next one here is let's talk about the architecture of Helm 3. So the Helm has three basic architecture here. It has the Helm CLI. This is the client-side interface for managing Helm releases, and then the second one is what is called as charts. So these are bundles of Kubernetes resources and configuration files that you want to or you're managing or you're running. And then the third one is the repository. So this is just where charts are actually stored, and this can be private or public, as the case may be, bearing in mind that in most companies, within actual companies, most charts are stored as private or stored in a private repositories, probably for security reasons. And then there are also a few ones that are open source, where you can just get on the public repository. But obviously, when you get them, it's essentially that you apply some security measures and then just while before you use them, to avoid some malicious code getting in. So let's talk about Helm 3 enhancements. Well, from the basic, if you obviously know about Helm, or you are used to Helm in the past, the Helm chart in the past it was called, I think, Helm 2. The Helm 2 work with client servers sort of architecture, but in this Helm 3, there's no longer anything like that. So no server-side component, the client interface interact directly with the Kubernetes API, and it also has improved security as well, because there's no direct integration with Kubernetes back enhances security. Okay, so obviously, I think I kind of skipped this in a minute, but in this Helm studies today, I'm assuming that for you to actually just be learning Helm, that you're used to Kubernetes, and you obviously like you know your way around Docker and containerization already. So, but that's my assumption. So, also for you to actually install Helm, there are some prerequisites as well. Some of the prerequisites, some of the prerequisites are like Kubernetes. You've got to have a Kubernetes cluster already running, or that you have access somewhere. It could be like your local ones, like all the minikubes ones, kind, or maybe things like the cloud providers ones, and like GKE, EKS, and AKS. So it could be that. Also, that you have a functional kubectl installed on your machine that you can use to actually interrogate those the cluster that you already set up. And again, the basic knowledge of basic command line interface, some things like how to use terminal and things like that, how to use curl, wget, all of those things, that those are like the basic prerequisite that you need. And the fourth one, again is network access. I want to believe that before you begin to talk about Helm, that already you ensure you have network access to your Kubernetes cluster. So because I mean, what I mean really is that you can access the cluster, and then obviously that you have the corresponding permissions for you to go ahead and deploy things. But then the easiest way to actually learn without spending so much money on the cloud infrastructure is to probably like bootstrap a local cluster using things like kind. I think I kind of prefer kind, but you can also use Minikube and things like Docker Desktop Kubernetes. That there is a Kubernetes now in if you're running on a MacBook, the MacBook Docker Desktop has Kubernetes enabled within it, so you can just go and toggle it, get it on, and it will be up and running. So there are many ways to like get access to a cluster, but we walk through on all of that. The other optional prerequisites are like obviously you have basic understanding of YAML. I mean, you don't have to like understand the YAML with the first principle, but you can just like have a basic understanding of how YAML works. And then again, the Git version control system to actually check in your code and things. But those are like optional in my mind. So let's move on. Well, so the next stage here is how to install Helm on your machine. Well, it depends on the kind of machine that we're talking about here. But we'll go through just a few of them. But manually, if you really want to install Helm, especially on a Linux machine, essentially just to like download the file, the probably like gzip if it's in a MacBook, or like on especially Linux, just gzip, download them and move them to any bin directory that is already on your path, on your system path, and then just run Helm version. But essentially, if you want to run it on things like, let's say for instance Windows, I actually advocate installing things on a machine using the package manager. So for Windows, I think you can do the easiest way is to use a choco install, especially when you're on a PowerShell script, or maybe use something like Scoop. So Scoop install Helm. If it is choco install Kubernetes hyphen Helm, as you can see. So that's the easiest way. I haven't got a Windows machine. I am using a MacBook machine, but we'll be seeing that in the series as the journey unfolds. Okay, so if you are on things like Debian Ubuntu series, which is a Linux machine, so all you need to do is to use the apt package. Okay, so a sample of this, following this example might be easier for you. Just read if you want, just copy this code here and just paste it on your terminal, and there you are. Probably you can just go to the website of Helm. We'll go to all of that as we journey along. And then again, if it is Fedora, obviously do the needful here. sudo dnf install Helm, and that should do that for you. So let's move on to how to install Helm on a MacBook. Well, each of these things I'm showing you have different ways of doing that, but I'm just showing you the easiest way, especially going through the terminal actually. Okay, so for as I was saying, so on a MacBook it's easier to just use brew to run things, and here to just do that is just brew install. I think this is the option I actually went for. Okay, so let's move on. So the next one here is, let's obviously before we dive deep into Helm, let's look at the structure of Helm. Obviously we're still going through the theory. We would see all of this in practice in the next series. But here you can see once you create a chart, a Helm chart, but you also hear me obviously interchange them as chart. But once you create a Helm chart, it would be in this structure here. It would be okay. So it would be in this structure here. It would be like the things you have would be the chart name. If you open the directory inside the chart, you will see chart.yaml, and I will be explaining what these things are, but this is how it would look like. Here is value template. This is a subdirectory within this my chart directory. Within this directory here, you would see deployment.yaml, service.yaml, ingress.yaml, and a few other things, and then the chart directory again. And then within that, you see probably, if you may or may not see, the readme.md file. But so let's talk about each of these things. What are they? So first of all, the chart YAML, what does it contain and what does it do? Well, it contains metadata about the chart that you created. So like the parent chart or the specific chart that you're working on. So this is where you define the name of the chart, the version of this chart, which can be incremented over time. And then with this way you define the app version that you're deploying, and the version of the application that you're going to like be orchestrating with this chart. And then the description here, obviously you can just give a detail or brief description of the application you're trying to run, so that other people, when they come to this chart. So this is basically the chart.yaml is just a place to provide basic metadata for the chart so that people can know what that is, and then the chart itself can use it over time to run. And then the second one is what we call values.yaml. So this one is really key. It is important that you really understand the value if you are actually going to be using chart. So what is this? This is like a file for default configuration of values for your template. Users can override these values when installing chart. So this is where, in a layman term, this is where you put different kinds of changeable values that you want to impute into your chart at the end of the day. Okay, let's see example of chart.yaml. Let's start with the chart.yaml, the previous one we just talked about. The chart.yaml would look like this typically. So it would say app version v2, my name, chart name here is whatever that chart you created is, it would be here. So, but you can change this description as well. You can just, I mean, you can go like more than one line and just provide more things here, but obviously keep it simple for now. And then the version of the application and the version of the chart, and then the version of the application itself that you're deploying. So essentially again, this chart.yaml contains metadata for the charts such as name, versions, and descriptions. Let's talk about value now. So values in charts is contains default value for the charts. This value can be overridden when deploying. Obviously, we said so. A typical values.yaml would look like this. It would have probably things like replica count. Replica count is just the number of ports that each infrastructure or each resource, like deployment or things or container that you're trying, or image, I would say Docker image that you're trying to run, how many data will have. It is used in creating the replica set count. This is image, and you can have subs in each of these definitions. So here the definition of image, and you can see that the both repository and tags are sub within this image. So, and then obviously when you want to reference them within your application, which I'll be showing you in few minutes, it will still be like to access them in this order. And then you have service again, you have service type, which is cluster IP, and service port, which is port 80 in this case. So let's see. Let's move on, but obviously, so this is the next one you see is which is the third one we talked about, is template. So what is template? Simply a directory that contains the Kubernetes manifest that defines the resources to be created or managed or to be provisioned. And then this contains essentially three key things. Well, there could be more things there, but the three basic things that usually are in these directories are like deployment.yaml. This deployment.yaml will define the deployment resources, as you know, because I'm assuming that you already have a basic Kubernetes, knowledge. So this deployment is where actually, if you don't know anything, it's simply just a place where you define the sort of like the ports and things, the characteristics, how you want your containers to be provisions and things like that. And then the service is like, obviously within the cluster, when you create things, there would be a service that would help you to connect onto those resources, like probably for instance pod, and then expose them or probably like route them to or connect them up to a different resource within that. So service is simply what helps you to talk to or access those resources that you provision. And then ingress is obviously the one that helps you to actually, probably in most cases, expose it to the wider world. So these three things are what will be within this template directory. And you can include other templates as needed. These templates can utilize values from values as well. So within this place, they can actually access values if you need to. Well, the fourth thing you have within that when you create a chart is your chart directory. It is a directory for any dependent chart. So if your chart is going to make use or reference to a different chart, well, this is where you have opportunity to include them. So and you can just include them into your own chart, and they can access it. Say for instance, you're trying to create a chart for microservice, say something like a Spring Boot API, REST API. So what you can do is that Spring Boot might depend on its own database. And in that case, you may want to have, like, let's say, for instance, a Postgres chart included into your chart, and then configure them in such a way that once your Spring Boot API comes up, it would access those database that it will provision as is coming up as well. So something like that, just at a basic level. So let's move on. The fifth one is like readme.md. This is just a documentation file that describe how to use the chart, including installation, instructions and configuration options. So basically a place where you explain what you are actually doing to other people, probably the team members or people you're collaborating with. And then additionally, you can have things like Helm ignore file. Within that, once you create your Helm chart, it's a file similar to like git ignore, which specifies files and directory to ignore when packaging. So when the Helm is trying to package resources that it needs for deployment, it will just ignore anything you mention or list out within there. So that in that case, it's just to ensure that things are not bloated up actually. And then again is the chart.log. This sometimes gets automatically generated or created. Just a log file that ensures that the chart dependencies are consistent between installations. So an example is if you include, like I was saying previously about the Postgres database chart, if you include that and specify a specific version, that is where to go and dump it to make sure that every single thing else is actually the same version that you mention in your installation, and that way you keep things consistent actually. So let's move on. So here is an example of deployment for those people that haven't actually seen deployment before. But as you can see, in this case, this file was automatically generated It's just a simple example of deployment.yaml. Why am I showing this? Basically, just to sort of like give you a sense of it before we go ahead and create one. Okay, so I mean, there are a few things we can talk about over time, but for now, it is just deployment is just things that, as we said, is just what defines the resources you're trying to provision. But let's journey on. This is just an example. We will be making reference to this example in a few minutes. So for instance here, let's talk about values. Okay, values.yaml. Obviously, as we described now, that values is where you keep your key value pairs, and then, or which gets read inside of your resources like deployment and things like that, or ingress or service. So here is a typical example. You have a values.yaml, and then here it says replica count is 2, image again like repository, my app. You can give any name here. This is the actual value. This is key value and pair thing. So this is tag. This is latest. Obviously, bearing in mind that you should always make a reference to the actual, a specific version of Docker image each time you're like doing things in real world. Service type, like that, cluster, ingress. There will be more, to come. But here, the only thing I want to point out is that whatever value that is defined here as this is value.yaml file, there will be a correspondent, probably just within, like in this case, this is deployment. Within this deployment that you saw on the right hand side, here is the deployment. An example is in this deployment you have image, and this image, obviously we don't know the path. The Helm chart gives you opportunity to use things we call ginger templating to actually provide image on the values on the fly when you're trying to provision those things. And for instance, in this case, image, I mean, you can go ahead and hard code an image path, the repository, and the tag number of the image. But obviously, as it gives you this Ginger 2 templating format, you can actually just reference those things within the value. Example is image.repository. Here you can see, well, because it comes from value, then the standard is that you use the values in capital. So dot values dot image here dot repository, as you can see, then it will read this thing here and feed it in. And then again here you can see that there is a colon, and then you have again. So this is basically an interpolation of values, the way we say in programming language. Again, we are reading dot values dot image and dot tag. It will just come and read. So this will be my hyphen app colon latest. That's what this will read eventually. And then again, when you're running the application, it will give you opportunities to sort of like put whatever it is, define the Docker images and things you want to use over here. Okay, so moving on. So now let's talk about, still on values, but let's talk about overriding values actually. So in this value thing, if you want to probably just at the runtime, because at the minute you have got your default values, all the values that all the key pair values that are defined within this value.yaml are called as default values. But at the runtime, when you want to like install this Helm chart, you can actually just use a flag called set to actually specify or override them. So an example here is if you want to install Helm chart, you can just say Helm install my release, which is the name. This is just a custom name that you give to your installation, and then this is the name of your chart itself. But then if you use -- set and then mention anything that you have defined here, an example in this case is replica count to 2, but in this case I want to experiment to sort of like set the replica count to 3. That's possible. Again, you can just, you can go crazy with this, but you can also, I've just done 2 here so you can kind of see that it will work. So in this case, it will just like, this will set replica count to 3 instead of 2 that it was defaulted to in the values.yaml file, and then again image.tag will be set to v1.0.0. So that's how to override things, and it's really a cool feature that is there on a Helm chart. And then again, the third thing about these values is that when referencing values in your template, there are three ways really. You can do direct access, which is obviously I've talked about this Jinja 2 templating. So this is when you use double curly braces, open and closing ones. These are like obviously how you can then do interpolation. So you can do direct access to access a single value. But obviously to do that, simply just do dot capital letter V values dot key here. That will just go and read what the key is within the value file. That's good. There's a second way of doing that, which is using nested values. In this case, we use dot notation for nested values, like if we will say dot values dot image dot repository. So you can see this is nested, and this is the previous one that I shown you before in the previous slide. So here you can see that it's nested. This is the first, probably like the parent, and then this is the child, kind of. So it's nested within, and then you can, this nesting can be to any level. You can go like image.repository.something. You can just keep going on. It allows all of that. And then the last one is using what we call as default values, which means, kind of hard coding things, but also it gives you option to look for, probably like seek for something. So it will just go and listen. If you don't provide, then it will default to something. In this case, this is the example here. So here you use default keyword function to provide a fallback if the value is not set. So an Helm chart in this Jinja 2 templating thing concept, it works from the right to the left. So here it will first of all try to read this value here, which is dot values dot image dot repository. But if it wasn't provided, it will simply default to my app in quote here. This is the default in case it has gone on to actually look for repository and it couldn't find it. It will just default to this one again. So you can also do that here as well, really. But here is the like the nested one that I talked about at number 2 here. And then again, you can have like the direct access as well. Okay, so this really majorly about values. Now let's go to the one I regard as very important one. So this helps like matured or like experts or like people who are really confident or competent in the use of Helm chart. You can do without this underscore helpers.tpl file. You can do without it, but this TPL files, what it does is in a Helm chart, it's a special template file used to define reusable template snippet functions, variables that can be referenced throughout other templates in the chart. So if you want to kind of centralize things, more like what the values do, but more. So what this one does majorly or does well is that it helps you to define things like functions, or maybe programmers who may want to call methods, things that is a reusable component that is kept somewhere, and when you call it, it will execute what is inside and gives you results. So this TPL helper.tpl file helps you to do that. So you can reusable templates. It defines the commonly used patterns that can be included in multiple templates. If you define it once and for all, and then you can then reference it across the entire thing. And number 2 of the purpose of this is that, obviously, again, as we said, is template function create custom functions for complex logic that can be reused across different templates. And then again, consistent namings. So it helps you to standardize naming conventions actually. All right. And it has benefit as well. I don't suppose we should be going into it, but it encourages reusability, as you can see already, maintainability, because update a single help function to reflect changes throughout your templates. So if a function changed, you simply just get into that function, change it, and it will reflect wherever those functions have actually been invoked. And clarity, really, you can just get into that function because it's centralized naming and labeling conventions as you want it across the entire chart, and makes it easier to understand. And as well as defining things one place and then and it applies everywhere else. So what is the functions of actually, let's go inside, let's go deep inside the template folder or directory. So previously we've seen this chart values, and then this template. Previously we saw that this template had deployment, service, and ingress, but now I have included this underscore helpers.tpl. This is typically where you keep it in a chart that you created. Most 9 out of times, once you use chart, Helm generates to Helm create functions to create your chart, this would come bag and baggage with it. It would just appear there magically. So let's move on. So let's see an example of, or probably like a typical things that are usually within this help others function, because we talked about defining a function and it to be reused across the whole template. So this is an example of it. Here I have just kindly included just 2 functions that was auto-generated when this chart was created. In this case, it just says you can make a comment and just say generate the name of the application. So here you use the word minus, so within the junior template 2 thing, just hyphen define. Here is sort of like we're creating a function here. Define, this is the function name my-app.name. So what would that be? Well, each time you invoke, and this is the end of it, like if you've ever used Python, this is sort of like similar to that. And then if you want to like invoke this now, you will simply just invoke the name here. You say include. We'll see that in a minute, but include, and then you mention this name here. This is the name, and whenever you mention this, whatever that is within here would execute, really. And that's what it is. So an example is we've defined this even within itself as well. Within this same file, you can also like now reuse this. So you can kind of see here that my-app.name has now been defined. Each time it's invoked, it would evaluate these things and find out what .release.name .chart.name would be, and concatenate them together and throw it back at you. So I mean, it's sort of think about this like there's a return keyword here, because it will return whatever that is the evaluation has come out to be. But also this can now be reused within here, as well as within like deployments, ingress, and other places we're writing code. So in this case here, we're trying to define what my app.labels would be. Pay attention here. This is my app.labels, but this one is my app.name. In this my app.labels, we are also going to include this to be that. So you can see that just the word I mentioned, that to use this, you just say include, and then you mention the name, it would find it. You just go and evaluate this and then bring it back. So in this case, when you want to do your label, it would like, label is like kind of a key value pairs. So this is the key, this the value would then be whatever this thing evaluates, this thing comes to be. So you would just put that thing app : this. So that's that, and then that's the end. I mean, it has other things, but I just brought to show you. So I mean, what I'm trying to emphasize is that you can use that within the actual Kubernetes manifest, like deployment and ingress, but you can also use them here. Right, let's move on. So if you want to use it, this is just a typical example that I got. If you want to use it within an actual Kubernetes manifest like deployment, it's still the same. All you just need to do, like in this case now, we want to say the inside within deployment that the name, the meta name here would be, well, we don't know. We have defined that. So this will be include my app.name dot. It would go and find whatever that is and just put this dot there. And in this case, it's include my app.labels. It would obviously, in this case, it will show you app : whatever this name evaluates to be. And then again, we'll talk about all of these things as we journey in this series of Helm Chart. But this is just an introductory video to things so that by the time we start going into details, you kind of understand. But in this case, we're saying once you've done this, indent it to 4th places. So you would indent, and then bring it to where you want it to be. So these are special functions within that Ginger 2 templating thing. So I thought I should just explain this include keyword. That's how it is used. Again, here, even though I didn't highlight this one as well, this is how it was used. Image is include.image my app.image name, and then you just include whatever that image function was defining to just include it here. Okay, so let's move on. Again, so more example. This one is specifically for service.yaml. In this service.yaml here, you can also see, so it can be used within itself and in other resources, as I said. So in the service as well, just include my app.name. Again, here is another example. Here is another example. So it can be reused everywhere and one place. Okay, so now we've seen like the major or the critical path of Helm chart. Let's now talk about how to like the working commands, the basic things or like the basic workflows within Helm charts. I mean, there's still other things to see or to be seen, but let's take our time. In this series, we'll talk about every single one of them, really, possibly. But let's talk about the commands at the minute because I think it's time for it, really. So when you want to work with Helm chart that is already created by someone else and is pushed into a repository somewhere, all you just really need to do is to find the address of that repository. In this case, is an example here is charts.helm.sh/stable. So here is the address of that repository. You need to like include that address on your machine so that you can then pull things from it. That is how it works in the repository, and the command is helm repo add stable, and just give it a name, and then you can just do that here. So this adds the official stable Helm chart repository to your local machine or to the local server, wherever you're running things. And then once you have done that, you can actually just run an upgrade command if you want to actually go and upgrade things, or you can list things. But now in this case, the second example here will be like after you've added it, it now knows the address. You can then do installation of things from that repo. You can then say find specific things and say helm install. Obviously helm install is used to now deploy the actual chart that you want. So from the stable repository that you added, because you called it stable when you added that repository, so you can just deploy things and find sub things within it and just deploy that. You can also list things, actually list all the active releases in that cluster, in that repository that you've just added it. If you do Helm list, it will list every single repositories within that version, and you can kind of see what is in there. You can upgrade. I mean, this upgrade is used to upgrade a release, something that you already installed. I mean, when they use the word install in Helm, they are generally talking about kind of not really like creating. They are talking about actually, deploying that manifest, and that's the word they use is install. So they sometimes you see Helm install or you see Helm upgrade install. Obviously, when they say upgrade install, it will just go and say if anything is out of date, it will just update them and then upgrade them and then install that. But install is largely just to sort of like create, sort of deploy that manifest, really. And it's just an equivalent in when you're just doing kubectl minus f, just to specify the path of the manifest, and then you just specify the manifest itself and just say apply kubectl apply minus f, and then you specify the path. Is just the same thing, just to deploy things. So rolling back as well. So let's say things are running. Let's say you've done version 1, 2, 3, 4, 5. You're just moving on, incrementing the app as the new Docker images being available. You're just deploying, deploying new things. But you can roll back to the previous one as well. Just you can do Helm list and just find the version and just specify that version, and you can roll back. So let's say you did Helm upgrade, install something, and then you went to version 2 and version 2 crashed, or there's an issue, or it may be some people are in production or wherever the deployment is, there's an issue or conflict. You just need to roll back so that customers can continue to use the application. So you can just quickly roll back. It's a nice feature. And then some people call it version control within the Helm, but it's just a revision control. So, and then the not the last one really, but the major one is once everything is once you're happy, you've tested your application, and especially in the test environment, you just want to bring things down. You just do just opposite of install is to uninstall. Just get it completely, remove the release from your cluster. It'll be gone. So if you say uninstall, you find the name of that that Helm release you done, and you just put it here, and it will just uninstall it completely and delete all the appendages it came with. Well, number 6 is here. Let's talk about on this 6. Let's talk about, because we talked about this overriding these values previously before now. Okay, so we talked about this before. It's kind of a repetition, but I left it here on the notes for you to sort of have an example again, different example. So, but obviously, if you want to install, which is like deploy the Helm chart, you can just, this is, in this case, is to give the Helm chart a name and then call that chart wherever that you created it. If it is the one you manually created, if it is the one you just added, you just call it and then override the value. So as we said, so let's move on from this one. And then again, the other thing I want to mention is this values.yaml is really very important, in the sense that you can make different values file for different environments. Okay, so let's say you have production, QA environment, you've got like a pre-production, and you've got development environment. You can create those 4 or 5 values. I mean, if you create them with this name values.yaml, they would conflict. You can have 4 files within this name. So Helm gives you the opportunity to like call it whatever it is you want. So you can create them, and then when you want to run or like deploy or install your thing, you just do Helm install, give it any name you like, and then specify the path to your chart that you created, and then you just use -f and you specify the custom value. So you can say dev-values.yaml. It will just read the values off of this one. And then if you do like QA-values, it will read values from that one. So that's the, unlike this way that you are overriding this one. I think this one is specifically better for CI/CD when you're running things on a pipeline. But then this one, that's just my opinion. This one might be much suitable when you're developing things locally. You have like a value file that you don't want to check in, that is specific for you. Once you like specify the path, it will just read from that. Okay, so let's now get to number 7, which is the packaging and sharing of Helm charts. So you've created your Helm chart. Congratulations. The next thing you want to look to do is to like, obviously, in fact, before you've created it, now this is the command to create it. Simply all of those things we've been talking at the beginning, which is how to like create a chart, is just this single line of command, which is Helm create, and you just give it any random name here. It will just bootstrap like a Helm directory for you, and you can just go and make a few tweaks and you're ready. So Helm is really good to, it's really like a very good thing that helps you. In the past, I remember like sitting down to write Kubernetes manifest. I'll just Google, when I was first starting off, I'll simply go to like Kubernetes website and like grab a deployment template and start to tweak, or maybe like go and grab service.yaml and start to be manually handcrafting all these things. Well, with Helm, this single command would bootstrap it, and all you have to do is to like tweak it to suit your need, and then you're up and running. So it makes creation of manifest quite very easy, really, I would say. I know I'm overselling Helm to you, but I don't really work for them, really. Let's move on. So 7.2 here is talking about packaging now. So you created it now, you made the changes, you want to like now package it. So for you to actually push it to a remote repository, you need to actually like package it, and then before you push it somewhere. So how do you do that? Simply just run a command helm package my chart. So this is saying once you are customizing your chart, you can package it, and it creates .tgz file, which you can share or upload to a Helm repository. So this is just making it like deployment ready, or like probably like shareable now. You're getting it to be reused. So just like other artifacts really in programming. 7.3 here is talking about hosting a Helm repository. So in this case, to host a Helm repository, simply serve the package chart file over HTTP and provide the index file. So index.yaml file. So in this case is helm repo index dot, and it will just this will generate index.yaml for your chart, and you know, things will be ready. So let's talk about because over time we'll start talking about the practical scenario, but all of these things we'll be learning. There are a few things this can be applied to. The first one could be deployment of web application to a specific environment configuration. So you think about it. If you have a web application, say for instance, maybe like something like Next.js or like React as an example, you can take it on, like create a Helm chart for it and just see how you can, you know, play with it. But we will be doing this over time, but for now we're just talking theory as the introduction goes on. So here, let's repeat a few things here. So how do we add, these are like commands that can save you. So how do we add Helm repository to a local machine? Again, we've seen this, but it is essentially Helm repo add repo name, and then the URL. It will just press enter, it would add it all. An example here is the popular one that we use in the industry, the open source one is chat.bitnami.com. And let's say you're adding the Bitnami itself, the entire repository, it would be helm repo add Bitnami, the address /Bitnami, because within this .com there could be other things. So this would appropriately add what you need onto your machine. Second command that can help you, again, as we said, is helm repo list. This is to see the repository within that you have added, you know. So you've added, let's say for instance, Bitnami. If you do Helm repo list, it will show you that this is now added, and it's going to link this URL to this Bitnami, which means the next time you want to do things with Bitnami, you can simply just say probably like Helm install or Helm upgrade install Bitnami. It will know where to go and get it if it's not on that machine. Okay, so that's just sort of like mapping. The third one that I think is important is Helm repo update. Again, very simple, just to update the repo that you have locally, because there's this repo in the cloud or in the repository, wherever it is, and you've got a copy on your local machine. It's like the same thing if you've ever used Git, is to do Git fetch and pull origin main. It will just go and update what you have locally on your machine. Again, you have searching for chart in a repository. So if you want to search for a specific thing, let's say in that Bitnami one, Helm search repo, then type the specific thing you want. An example is within the Bitnami. It has SQL, MySQL, SQL, whatever, different things, Nginx, all of those things will be there for you to actually just use quickly. So you can search for it. Installing chart, again, this is, as we said, is Helm install. This name is like custom name, any name at all of your choice. But then this got to be the path of that repo. So if it is like the custom one, if it's the Bitnami, it will be Bitnami /MySQL. If it is the one you made by yourself, you don't need this /. It's simply just give the name of your chart here and it will be gone. So an example, Helm install MySQL. You're giving it a name. This is what you want it to, the release or the revision to be called within the within that releases you're doing or deployment, and then you point it to it and it will do that for you. The sixth one, again, uninstall. We've seen this before, but typically when you install this, you give it the name, a custom name called MySQL. If you want to get rid of it, it's still Helm uninstall MySQL and it'll be gone. So that's how you get rid of it. And then again, the seventh one is removing a Helm chart repository. The Helm chart repository that you added on your local machine can be removed if you no longer access it. I mean, there's no point leaving it cluttering on your machine. You simply just do Helm repo remove bitnami and it'll be gone. So another example or scenario you can think of is real world scenario. I mean, I'm just like evoking your mind so you can kind of think, is using a stable Nginx chart for hosting a website. I mean, in this case, you can think of Nginx as a web server, ensuring a quick setup, reliable performance of the application. So just see how you can use like an Nginx, probably just to run something like a React application. So that's an example there. Okay, so and then one more thing really here is using Helm templating command. This is I mean, I hardly use this, but it's simply just Helm template, the release name, and then the chart itself. It will just generate a template for you so you can see before. There's also like where you can add a flag as debug just to make sure things are fine, but that template will spit out like, you know, like a full version, the fully created manifest of Kubernetes, so you can actually see. Like, so very last things, let's talk about best practices within Helm. First one is version control for charts. So it stores chart in version control system like Git. So please do that, store that, but don't store your sensitive details really. I don't think we need to like overemphasize that one. The second thing could be in CI/CD integration. So automate deployment using CI/CD pipeline really, so that CI/CD can take over and be doing that for you. The other thing I would kind of consider as best practice is testing charts. So you can, I mean, when charts are created, I didn't talk about that one, but it sort of creates a unit test for you, kind of a basic test. You can expand on that test, but obviously use Helm test to validate chart functionalities before deploying to production at least. I mean, you can do your things without tests locally, but when you want to share this chart, make sure you've done your test properly, really. But I have to actually emphasize that in this series of Helm, there wouldn't be anything like sort of talking. I don't think we'll dwell too much on Helm test. It's easy, you can always just read it up, but I'll be dwelling on the important concepts as we journey. And the last one, that is the security practices. Obviously try to implement Kubernetes RBAC security network policies to secure deployment. So make sure any application that is not supposed to be exposed to the public, please don't do that. I mean, I encourage you to like have a local cluster, not even the cloud one, because once you provision a cloud cluster, your money starts to count. But just provision things, at least things like kind, or use it to test. Those are like your local clusters or Minikube or things like that. Example of those things, let's talk about scenario again. I like to bring scenarios, is to deploy a microservice architecture with CI/CD integration using GitLab. So this is like a real world scenario that in production really you get to like use something like this really. But just this is something to think about. You might not be able to do that now, but these are the things that we'll be looking at as we journey along on this series. So things to think about then would be store Helm chart in a Git repository. So once you created it, tested it locally, push it up to a GitLab repository. In this case, it says it's a GitLab, push it in a GitLab repository, create a CI/CD pipeline to automate the testing deployment processes there. Okay, so before we conclude, let's talk about official website of this Helm chart. So Helm has an official website. So let's actually come out of this. Okay, before I come out, in conclusion, we have talked about Helm 3.x series, and the benefits it brings to your deployment. And I suppose those that I'm talking to today are just those who are already familiar with Kubernetes. That's the prerequisite for the course. I know I didn't specify that, ab initio at the beginning, but obviously for you to get on with this, I suppose that you're already used to Kubernetes and containerization and Docker. And then again, mastering Helm features is crucial for effective DevOps practices and workflow. Question and answer, please drop your question and answer in the comment sections, and I'll be looking at that. So before we exit out here, let's go to the official website of the Helm chart. So here is official website of the Helm chart. They have like loads of resources here, especially some of these commands that I was talking about. They have like detailed description. I mean, I intentionally didn't want to screenshot all of this to put it on my note, because once I do that, then this is they can be changing things. You can see that every single release they are doing like version control here. When they are doing this, then my notes will be stale, and I'll be teaching you guys like an old school thing. So I want to like keep up to date, and that's why I'm bringing you to their official website. So you can see their website is helm.sh, and then you can go to their doc. They have lovely documentation. So you can see here are chat management. We talked about a few of these. This is install and uninstall. This is for upgrade and rollback. This is for just practice. We would practice, a handful of them. This is to list, add, remove, update repositories. This is basically sort of managing chat repositories, and then release monitoring here. This is what you use, and it's usually like Helm list. Here is to get resources that obviously things download release information that you've done. I mean, with Helm, once you've initiated or like you've started working with Helm and you have done Helm install anything, you can always combine it with these Helm commands, with kubectl commands. It will help you to query your pods. We'll talk about all of those things. Help you to query your services, your replica set, your everything really. Deployment, it will just show you all of that, your ingress, all of that. So that's basically what people do. We combine those two commands together. They all work in tandem. So also the other thing I want to show you is the installation as well. I know we talked about it, but here would give you, I suppose this would give you more detail than I have done or I have shown you. Like this is manually installing from binary. This is installing from scripts. This is if you want to use a convenient script here, just run these three commands. Brew, again, here it is. Chocolatey, choco install, Kubernetes-helm. This is for scoop. This is for window. If you on window again, if you window has three really, helm.helm. So this is winget. So just do that if you want. Debian, I've just shown you this command. Just come here and get it, and then just do what you need to do. These are like major commands that you can use to do things. So using Helm. So we will start with this in our next series. Obviously, I think before we go to this using things, we would at least create our own or have created our own Helm chart. Get it ready for us to use things. So let's catch up in the next series. Thank you so much. Have a nice day.